Hello, this is part 2 of the video featuring how to do intro to application problems. This video will focus on how to find a cutoff score, or if I give you a percentage and you have to kind of work the problem backwards to find an original value. Okay, so at the beginning here, it says when you must find the value of x. So when you're trying to find an original value or original score, you can use the formula, and I just simplified this, x equals z times sigma plus mu, okay? Or in other words, the z value times the standard deviation plus the mean. Okay, and that'll give you your original value. And simply what I did was, if you can see up here above, I just took, multiplied both sides by the standard deviation and added the mean in solving for x. We can have a similar statement in terms of sample notation. The x value, okay, would be z times the standard deviation plus x bar, and that's doing the exact same thing if we have sample statistics. All right, let's try one of these. For a medical study, a researcher wishes to select people in the middle 60%, okay, middle 60% of the population based on blood pressure. If the mean blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that would qualify people to participate in the study. Okay, so when we start about this, okay, think about your bell-shaped curve. Okay, we know our mean is here in the middle, and it's talking about the middle 60%. So that means in between two z-scores, one to the right and one to the left, we're going to have 60%, which also tells you, since the curve is symmetric, it's going to put 30 on both sides. Okay, so 30% and 30%. Okay, so then using your standard normal table, for which you have one in your packet as well as in your textbook, you want to look up in the guts of the table the value of z closest to 0.3. Okay, so when I look up on my chart, I see 0.84 to be the closest value. And I'm going to put that as a plus minus because I have a z right and a z left because of this topic, or the description, middle 60%. All right, so to find out the upper and lower readings, I'm going to say, all right, z equals, I'm going to do negative 0.84 times the standard deviation is 8 plus 120, which is your mean. And if you calculate that, that's 113.28. To get the upper reading, I'll use positive 0.84 times 8 plus 120, and the upper reading is 126.72. So then we've answered the question to find the upper and lower readings. Okay, 113.28. and 126.72. Okay? All right, let's go again. Membership in an elite organization requires a test score in the upper 30% range. If the mean and the standard deviation are as given, find the lowest acceptable score that would enable a candidate to be in this club, whatever it is. Okay, so think about your curve again. And I always draw a picture so I can figure out what it is and where I am in the situation. All right, so it talks to me about the upper 30%, and I'm just doing decimals so I can use my normal table to help me. So if 0.3 is out here in the tail, I need to know what the area is from 0 to z. And if you remember, from 0 to the right is always 50%. If I do 0.5 minus 0.3, I have a 0.2 or 0.20. So I need to look up in my normal table, again, in your packet or in the back of your book, what the corresponding z value is for a 0.2. When I look, I see that to be 0.52. All right, so then my lowest acceptable score, and I may even say this is greater than or equal to, okay, because my lowest score or higher would get me in the club. So I'm going to say 0.52 times the standard deviation is 12 plus, I got a little crazy guy going on there. Hold on there. Standard deviation of 12 plus 115, which is the mean. And when you calculate this one, we fall in at 121.24, and that would be your cutoff score, or the minimum value to get you in the club. Okay, I think we're doing well. Let's keep going here. I'm here at number 16. It says, if the average price of a new home is $145,000, find the max and min prices of a house a contractor will build to include the middle, whoops, I just love this pen. The middle 80% of the market. Assume that the standard deviation is 1500 and the variable is normal. Okay, picture time. So if we're normal, we have a bell-shaped curve. We are between or the middle 80%. So I'm going to have Z right, Z left, such that in between here is 80%. So if the total is 80, that's going to tell us that we have 0.4 on each side because it's symmetric, and we've been through that part before. So using the standard normal table, you need to look up the Z closest to a 0.4. Okay, I have plus and minus 1.28. And again, it's plus minus because I have a Z on the right and a Z on the left. All right, so then to get the maximum and minimum price of the house, we'll do negative 1.28 times the standard deviation is 1500 plus the mean price is 145,000. Okay, and I get for this one lower price range 143,080. Okay, then using the positive Z 1.28 times 1500 plus your 145,000, upper price range 146,920. Okay, so there's your min and your max values. Okay, I have one more here. I guess we could do this real quick. A special enrichment program in mathematics is to be offered to the top 12% of students in the school. A standardized test shows a mean of 57.3 and a standard deviation of 16. Find the cutoff score. Okay, so let's draw a picture so we see what we're looking at here. Mean, and we've got out here in the right tail, top 12%. So I'm going to have a Z to the right. All right, so if it's 0.12 in the tail, and I know that it's 50% from the mean to the right, if I do 0.5 minus 0.12, I get 0.38. That's what I need to look up in my Z table. Closest to that 0.38 in the guts of the table, it's actually between two. It's a tie. So I actually just did 1.17, and I put a 5 in there to kind of split the difference between. All right, so then to get your cutoff score, we're going to say our Z 1.175 times the standard deviation of 16 plus 57.3. All right, so your minimum value here is 76.1. That's your cutoff score. Okay, might as well answer these little questions here at the bottom. Why not? So 18, given a data set, okay, so I'm down here. Given a data set, how could you decide if the distribution of the data was approximately normal? Okay, well, what's that mean to you? I'm hopeful you're thinking, look for a bell shape. Okay, where could you see that? Remember, bell shape is the same as symmetric. Okay, if I hear you saying histogram, that's a great idea. You could throw it in your calculator, make a histogram. You could make a box plot. Somehow you could look at a graphic representation to look for that idea of symmetry. Okay, what does the mean equal and the standard deviation equal for the standard normal distribution? Okay, well, as soon as it says standard normal, that's when we shift to a mean of 0 and the standard deviation is 1. Every time. Okay, every time. All right, lastly, we have some true-false questions. The area to the right of the mean is positive. True. Area is positive. The area to the left is negative. Okay, never. Area is always positive. Area. All right, next, the z-score to the left is negative. Yes, z-scores on the left side are negative because they're below average. And lastly, the z-score to the right of the mean is always positive. And that would be true because then you're above average. Okay, well, thank you so much for watching. This is video part 2. And our feature today has been how to calculate cutoff scores given a percentage of data known. Have a super great day.